Hello, and thanks very much for joining me today. I'm going to be giving a presentation on enhancing reverse osmosis and desalination efficiency using our technology, the Integro, which is an electrochemical water restructuring solution. My name's Chris Rose. I'm the co-founder and managing director of Side and Water. So a little bit about Side and Water. We were formed in 2019 and began trading in 2020, and we're headquartered from Scotland in the UK and San Diego, California in the USA, describing ourselves as a technology innovator. The focus of our efforts is on electrochemical water restructuring, otherwise known as water conditioning, and with the primary application of the technology being limescale prevention removal, and latterly with a concentration on filtration efficiency, specifically reverse osmosis and desalination solutions. We've got good global activity, having supplied systems and solutions to a number of countries around the world, but the focus of our efforts have been in the UK, Benelux region and Spain within Europe, and North and South America. So what is the Integro technology then? You can see from the picture on this slide, it is an inline stainless steel pipe manufactured in either 304 or 316 stainless steel, or for desalination applications we tend to favour super duplex, and that's connected to our control box, which is introducing a controlled flow of electrons into the water. The purpose of this is to alter ionic behaviour and to disrupt the adhesion of those scale-forming minerals or salts. There's no chemicals, no sacrificial media, and the system requires little or no maintenance. We do recommend an annual check of the equipment just to make sure that nothing unforeseen has happened, but there's no sacrificial components to the system, and there's no scheduled servicing on it. The applications of the technology have been proven across multiple sectors, multiple industries in heating and cooling systems, and we're doing a lot more work with reverse osmosis applications now as well. So exploring the traditional applications of our technology, which have been centered around limescale prevention and removal, we do just that. We prevent and remove the vast majority of limescale through hot and cold water systems. As well as that, another feature of the technology is helping significantly reduce corrosion. And this is achieved because of the injection of negatively charged electrons into the water, as opposed to stripping these electrons out of metal pipework and metal equipment as the water travels through. We have effectively left these parts of the system passive. There is a significantly improved heat transfer, which, very simply put, comes because we've removed that insulating layer or the limescale from the heat transfer surface. This leads to significant energy savings. We reduce maintenance dramatically. If you prevent and remove limescale formation on critical hot and cold water equipment, it will reduce breakdowns, it will lower maintenance call-outs, and of course this naturally leads to an extension of the equipment life. And then Legionella control, or reducing Legionella risk. It shouldn't be confused with us treating Legionella or treating waterborne bacteria. We don't. We simply prevent and remove limescale, which then of course reduces the resulting biofilm, and that's the breeding ground in which a lot of waterborne bacteria harbours and increases. So by removing that limescale, we significantly reduce levels of waterborne bacteria and Legionella within water systems. We should really be viewed as a secondary control measure. So having established just how well the technology works for the prevention and removal of limescale across multiple industries in multiple different parts of the world, latterly we've been looking at just how well the technology works in improving reverse osmosis and desalination efficiency. So let's look at some of the challenges that are faced. Of course, scaling on membrane surfaces and subsequent fouling reduces recovery rates, raises pressure, and of course increases energy consumption, a critical part. Anti-scalants are a typical method of dealing with this, but they add to operational expenditure, and of course there's the environmental burden. This leads to frequent cleaning and is shortening membrane life. The Integro is a chemical-free alternative to this. Now, when we say alternative, we should be clear. We don't typically replace all anti-scalant use, but we can dramatically reduce it and dramatically reduce scaling and fouling on the membrane. So what does the Integro offer? We're reducing scaling on membrane surfaces, as we've just discussed. We're improving flux stability, membrane permeability, and recovery rates, enhancing permeate quality by reducing ion passage. We're extending membrane life dramatically, and critically reducing energy consumption. We decided that it was necessary to get some independent validation and start to explore conditions under which we can improve the performance and optimize the efficiency gains that we're getting in RO and desal. So we partnered up with Cranfield University, who we've worked with for a number of years now whilst we've been exploring our technology. The MSc study that they conducted over the summer for us was using synthetic waters, freshwater, brackish water, and seawater, and exploring what the Integro did in terms of permeability, flux decline, and critically ion passage. So headline figures that came from the study in terms of permeability and flux saw that we had permeability gains from between 9% and 12%, and we reduced flux decline by as much as 41%. Ion passage was a really interesting area of the study for us. We looked at 3 specific areas, and we found that we reduced ion passage in particular with chlorides by 78%, sulfates by 94%, and calcium by 30%. So the results were incredible, seeing a dramatic reduction in conductivity of the permeate water. Some interesting work that Cranfield did for us was looking at a cost-benefit analysis. Now, bear in mind that this is a desktop-based study that they did, but with good sources used for the information and looking at a desal plant doing 100,000 cubic meters a day. The estimates that they came up with for this was a total saving when using the Integro of 1.22 million per year. So we're not talking about insignificant savings when using the Integro to improve efficiency. The gains can be really quite dramatic. Some other work that we've done was with an interesting Dutch company who were specifically looking at a reduction in anti-scalant. And that's come about because in certain parts of the Netherlands, particularly up in the north, they're not allowed to use anti-scalant at all. So the study focused on efficiency of the RO with no anti-scalant and no Integro, 100% anti-scalant use as recommended by the chemical supplier, and then no anti-scalant use at all, but using the Integro as an alternative to that anti-scalant. And it was a very small skid they were doing, testing at 85 to 90% recovery with just 3 meters cubed an hour of permeate being produced. The results for us were really interesting. What we found was that when the water was completely untreated, there was a 50% reduction in performance compared to chemical treatment. When we used the Integro as an alternative, there was 50% less scaling, so we didn't eliminate the scaling completely, yet we managed to retain 90% of the permeability. Critically though, and this was the very interesting part for us, our output of permeate remained comparable or higher in all of the trials. So although we didn't completely prevent all scaling on the membrane surface, we reduced chemical dependency by 50% and retained a similar or higher level of permeate output. Another very interesting study that we've been looking at recently, or trial rather I should say, is in conjunction with our partners Lubron, and they were looking at a very small RO system being used in a UK hospital in a dialysis unit, and this was looking at all areas of performance with the results that you see here are taken just about a week after the system was installed. So showing that you don't have to wait weeks or months in order to start seeing the results. They're relatively immediate. And quite staggering in this case. We had a 20% improvement in amount of permeate produced, going from just over 2,200 litres to 2,460 litres an hour. Recovery improved by approximately 5%, rejection rates were lowered, but critically, as we talked about earlier, we also found here that there was significantly improved conductivity in the permeate water, which was a hugely important thing in this application. So what's the Integro doing? What is a technical summary of the technology? Via the pipe that you see there and the connected control box, we're introducing a controlled flow of electrons into the feed water, which is altering the ionic activity and reducing the tendency for scale-forming minerals or ions to adhere to surfaces, and in this case, the membrane surfaces. So this conditioning effect stabilizes the hydraulic environment around the membranes without the use of chemicals, media, or the interference of other existing electrical processes. So it makes the Integro a perfect solution, either to be retrofitted to existing systems or to be designed and specified into new systems. So the Integro action can be broadly summarized down into two different effects, and the next two slides cover that off. We have the restructuring of the scale-forming minerals, which are designed to, as we've just talked about, reduce the scaling on the membrane surface. And the action there is taking calcium, or any of the other scale-forming ions, but concentrating on calcium here, which is of course positively charged. And as those ions are flowing through the Integro, the flood of negatively charged electrons in the water is leaving that calcium temporarily neutral and, most importantly, in solution, allowing that to harmlessly just pass through the water system. And this prevents the vast majority of scale formation. The second action is what we would term loosely as our wetter water action, or reducing the surface tension. By taking the existing larger water clusters as they pass through the Integro, the flood of electrons coming into the water are smashing apart the hydrogen bonds within those water clusters and leaving altogether smaller constituent parts, or down to individual H2O molecules. This dramatically improves the permeability at the membrane surface and allows the water to pass through more easily, as well as breaking other bonds within ions to make it more easily filtered out at the membrane surface. And it's this which is helping reduce the ion passage and improve the quality of the permeate water. So key takeaways from this part of the presentation. We've got significantly improved membrane permeability, less scale on the membrane surfaces. We've got a lower differential pressure and dramatically reduced energy consumption. We've got potential for much higher recovery rates. There's longer membrane life and fewer CIP cycles. And we've got simple integration into either existing desalination plants or RO systems, or indeed it can be specified at the beginning. The environmental impact of the technology is not to be understated, and I suppose the operational impact as well. The technology will dramatically reduce the chemical dependency that you may currently have. The aim would be getting to a stage where we have an entirely chemical-free pre-treatment, but that won't be possible in all situations. This is leading to fewer cleans, longer membrane life, lower OPEX and carbon footprint, and of course all of this is helping support net. The unique and incredible nature of our technology has led to us reaching the latter stages as a qualified team in the X Prize Water Scarcity Challenge. The competition is designed to drive advances in desalination efficiency, and Side and Water and the Integro has been selected as a qualified team in their Track B part of the competition. We've been recognised for reducing energy use, chemicals and fouling in RO and seawater desalination, and then we're now going through the final stages where the results that we've had so far will be rerun and independently validated, and we hope to progress further. That brings us to the end of today's presentation. So thank you very much. And don't hesitate to reach out with any questions that you may have, either to the email address below or via the contact forms on our website. For your ease, I've put on a QR code where you can download the Cranfield University white paper that we referenced within the presentation. And please, anything else, don't hesitate to reach out to us. Thank you very much and goodbye for now.